Hi everyone, in this lesson we're going to look at calculating original values without a calculator. Our first example is of a reverse percentage increase question. The price of a watch is £540, including 20% tax. How much is the watch before tax? So the price of this watch includes 20% tax. And the way we could think of this is that if the watch originally was 100% and we've added on 20% of that value as a tax, that leaves us with 120%. And this value of £540 includes the 20% tax. So what we can say is 120% of the watch's value is equal to £540. And we want to work our way back to find out how much the watch is worth before tax. We want to work out 100% of the watch's value. So what I'm going to do is I'm going to get a helpful building block. I'm going to scale down to 20% because I notice that if I divide 120 by 6, that gives me 20. And the reason I spotted that is because if I divide 12 by 6, it takes me to 2. Therefore, 120 divided by 6 takes me to 20. I'm also going to divide this by 6 as well. And I'll do that using my short division. So £540 divided by 6. 6 goes into 54 9 times, and 6 goes into 0 times. So 20% is equal to £90. And remember, we want to scale up to 100%, and I know that 20% multiplied by 5 gives me 100%. So I'm going to scale up to that. Of course, that means I need to multiply this £90 by 5 as well. 90 multiplied by 5 will do 9 multiplied by 5 to give you 45. So 90 multiplied by 5 must be £450. So my answer is £450. And this makes sense because if this is the price of the watch before tax, I'm expecting to add on a number, being 20% of this, to take me to the £540. Pause the video and give this question a go, and then we'll run through it together. So a comic book increases in value by 50% over a year. It is now worth £90. How much was it worth a year ago? So this £90 is after the increase of 50%. We always start with 100%. That's actually what we want to find out in this question. We've added 50% to take us to 150% relative to the original value. And it says the comic book increases in value by 50%. It is now worth £90. In other words, the 150% is equal to the £90. I then want to get to 100%, and there might be a helpful building block to do this. A helpful building block on the way to 100% is going to be 50%. And I know I can get there because 150 is divisible by 3. And the reason I know that is because 15 is divisible by 3. I'm going to do the same thing to the £90. I'll divide it by 3 as well. 9 divided by 3 is 3, so 90 divided by 3 is 30. If 50% is 30, I want to work out 100%. I multiply by 2. And I'll multiply the £30 by 2. So 100% is £60. How much was the comic book worth a year ago? Well, it was £60. We added on 50%. Well, 50% of 60 is half of 60. That's 30. If we add those together, we get 90. So I know I've done that question right. So our next question is a reverse percentage decrease. A coat is reduced by 25% in a sale. The sale price is £105. What was the original price? So the original price was 100%, but it was reduced in the sale. So we subtracted 25% in the sale, leaving us with 75% of its original value. And it says the sale price, 75% of its original value, is £105. So we'll let these be equal to one another. And as before, we want to scale up to 100% to find the original. In this case, the sale price should be lower than the original. Or we could word that as the original should be greater than the sale price. A good building block on the way to 100% is 25%. And I know that there are 3 25s in 75, so I need to divide 75 by 3 to get to 25. So I'll divide this by 3 as well. Set up your short division, it's non-calculator. 3 goes into 10 3 times with 1 left over. 3 goes into 15 5 times. So 25% is £35. And then we want to scale it up to 100%. To do that, we multiply by 4. So we're going to multiply our 35 by 4. I know that 35 multiplied by 2 is 70. Therefore, 35 multiplied by 4 must be double 70, so it must be 140. So it's helpful when we're doing some mental arithmetic to use these related calculations where we can. What was the original price? Well, it was £140. And that makes sense because if it was reduced by 25%, in other words, it was reduced by a quarter, in this case, that corresponds to £35, that gives me my sale price of £105. Pause the video and give this question a go, and then we'll run through it together. After a diet, a person's weight decreases by 10%. Their new weight is 72 kilograms. What was their original weight? So their original weight was 100%. Their weight decreased by 10%, leaving us with 90%. And this new weight, the 90%, is equal to 72 kilograms. Both of those numbers are divisible by 9. So I'm going to go down to 10% as my building block. And always, look at the first part of the number to see if it's divisible by 9. 72 is divisible by 9. It goes in 8 times. We're saying divide by 9. And then I scale up to 100% by multiplying by 10. So 100% of their weight is 80 kilograms. Okay, our next example is one where we're given the difference, and you'll see what we mean when we look at the question. Tickets for a concert went up by 15%. This increase added £6 to the ticket price. How much did the ticket cost originally? So there are different ways this question can be asked, and this is an example where we're given the difference. So tickets for a concert went up by 15%. So we know that we gained 15%. So we had 100%, the original price. They were increased by 15%, and this gave us 115%. Now we have to be a little bit careful in this question. This increase added £6. In other words, a 15% increase added £6. What that means is 15% is equal to £6. This was my increase in terms of a percentage, and this is my increase in terms of actual money. We use this as our starting point, and we want to scale to 100% in this case. Now, the reason it's 100% is because it asks how much did the ticket cost originally. Now, originally is my 100%. It may well have asked how much did the ticket cost after the increase, in which case we'd want to scale up to 115%. I'm going to divide 15 by 3 to get to a helpful building block of 5%. And I'll divide £6 by 3 as well, which gives me £2. So 5% is £2. 10% is going to be double that, it's going to be £4. 100% is going to be 10 times greater, it's £40. How much did the ticket cost originally? Well, originally is 100%, it costs £40. It did go up by £6, so the final price of the ticket was 46, but that's not my answer in this case. My answer is the £40. Pause the video, give this question a go, and just make sure you read the question really carefully. So a pair of trousers is reduced by 20% in a sale. This is a saving of £10. How much do the trousers cost in the sale? So the trousers cost 100%. They didn't cost that, that's how we represent the cost of them. And they were reduced by 20% to give us a value of 80%. That's the original, that's the sale price. Okay, let's bear that in mind. A pair of trousers is reduced by 20% in a sale. This is a saving of £10. 20% is equal to £10. Now, there are two ways we can go with this. We could work out the original price, we can work out the sale price, but our question has asked us for the sale price. How much do the trousers cost in the sale? We're interested in the sale price. We want to go to 80%. To do that, we multiply 20% by 4. So I'll multiply my £10 by 4. That takes me to £40. That is the sale price. That's my answer. The last type of example we're going to look at is where we have a recurring percentage. After a few weeks of training, Sarah managed to increase the distance of her weekly long run by 33.3 recurring percent. She now runs 12 miles. What was the distance of her original long run? Well, her original long run was 100%. She increased the distance by 33.3%. And that would be equal to 133.3 recurring percent, like this. She now runs 12 miles. In other words, this percentage is 12 miles. Let's write that more formally. We'll say 133.3 recurring percent is equal to 12 miles. We want to find the distance of her original long run, and that would be 100%. And it might not be as obvious how we scale to that from here. But let's reconsider these percentages as decimals. 100% is 1, and 33.3 recurring percent is a third. And if we do 1 add 1/3, well, that gives us 1 1/3, which as an improper fraction is 4/3. And this is going to be a more helpful value, I would say, in this case. So instead of 133.3 recurring percent, I'm going to write that as 4/3 because I know they're equivalent. So 4/3 is equal to 12 miles. And if I have 4/3, I want to scale to 3/3 or 1. But let's get 1/3 first. So I know 4/3. If I divide 4/3 by 4, I get 1/3. Let me divide my 12 miles by 4. 12 divided by 4 is 3. So 1/3 of her original long run is equal to 3 miles. Multiply 1/3 by 3 to take you to 1 whole. That's going to be equal to 9 miles if I multiply the 3 by 3. So let's turn that back into a percentage. So instead of 1, we'll think of it as 100% is equal to 9 miles. What was the distance of her original long run? My answer is 9 miles. Pause the video and give this question a go. Due to roadworks, James found that his morning commute time increased by 66.6 recurring percent. The journey now takes him 45 minutes. How long did his commute take normally? Well, his commute originally was 100%. He gained 66.6 recurring percent. And that was equal to 166.6 recurring percent. And it's this value that is the new journey time of 45 minutes. In this case, it's more helpful to think in terms of fractions. So 100% is 1. 66.6 recurring percent is one of those fractions you need to know. It's 2/3. So if we add 1/3 and 2/3 together, well, 1 is 3/3. And then we're adding on our 2/3. That gives us 5/3. In other words, my 5/3 is equal to my 45 minutes. Let's write that. 5/3 equals 45 minutes. And I want to work out the value of 1/3, so I'll divide by 5. I know 5 of these thirds divided by 5 would give me 1/3. So I divide my 45 minutes by 5 to take me to 9 minutes. 1/3 of the journey, or the original journey I should say, is 9 minutes. We want to work out 3/3 or 1 whole. So that would be equal to 9 minutes multiplied by 3, which is 27 minutes. So let's turn that back into a percentage. So 100% is equal to 27 minutes. If you're using our lesson booklets, you can complete exercises 1 to 3. Thank you for watching.